Okay, people. So yesterday we started talking about inheritance. We said that we have this small, simple employee class. It's a very simple class, but we wrote it, we implemented it, we tested it, it works fine. And now I like to write a new class, which is very similar to employee. It behaves like employee, but it is a little bit more than employee. It is salaried employee, maaşlı çalışan. I need to pay some money to this salaried employee every week. So the one way is copy paste everything from this employee class and do those additions, like the salary, get salary, set salary, etc. The other thing could be using inheritance. That's what we are doing in this case. Here it is, and this is my salaried employee. Here I am saying that, okay, salaried employee is actually an employee. Ignore this public keyword for now. We will talk about it. It's not that important. Okay, this is the notation. I mean, we never did such a thing before. We just wrote class Theophir, class PFD array, class something something, and the curly braces. Now we are doing this. Class salaried employee, don't forget about the attendance, everybody. Salaried employee is same as employee, but on top of employee, I have my salary, I have my get salary, set salary. Of course, this is a new class. It is different than employee, okay? It's a new class. Since it's a new class, it has to have its own constructor. Why? Because remember, with the employee, I have the name, social security number, just two things. Now I have name, social security number, and the weekly salary. Three things, right? So I have to get these three things from the customer of this class, and I have to set them correctly. But as you see, I don't have anything. I don't have any functions about getting the name, setting the name, getting the SSN, setting the SSN, and etc. Those are already inherited. Those are my functions, like my public functions. Since I am telling the compiler that I am an employee class, actually, I am same as an employee, okay? I can do whatever the employee does, okay? I can do whatever the employee does. On top of it, I can get salary, set salary, and I have this private data member. And I didn't like how the print check works, okay? I didn't like how it works. I am going to redefine it. It's not overloading. This is redefinition, okay? I am going to redefine it. Good. Okay, so let's look at the salary. By the way, I mean, this is the way. Do I have a main function somewhere that I can show you driver? Do you guys see it? I don't think that. No, I don't have it. Maybe this one. What is it? Yeah, okay. So this is how I use it, okay? Include. Why don't I introduce the other employee too? It is the hourly employee. Hourly employee is the same thing as, okay? Hourly employee is here. Hourly employee says that I am same as employee, okay? I can do whatever employee does, exactly the same thing. But on top of it, I am going to do the set rate, set hours, and get hours. And I don't like how employee works on the print check either. I am going to redefine it. The meaning of hourly employee is this. I am an employee, I will get paid, but I will get paid by the hour. How many hours I worked? I worked 10 hours. For each hour, I am going to get $10. 10 times 10 is $100 I am going to get. So this print check will print 100 on the check. But for the salaried employee, this print check will print this salary. So these three classes, employee, hourly employee, and salaried employee, they form a hierarchy of classes. And let me show you the picture itself. Okay, the picture is something like this. Okay, good. So this is my employee class. In my employee class, I have name, SSN, and pay. Okay. Those are my data members, and they are private. And these are my public functions, and there are a few more. This is my employee class. From the employee, okay, I have salaried employee. Salaried employee has get set salary, right, on top of it, and I have the salary data member, and I have this hourly employee here. So this is my diagram, UML diagram for the employee hierarchy. Okay, employee, salaried employee, and hourly employee. It looks like I did this too. I think I added this day of birth. Okay, date of birth, day of year, member of. I can do this. I can go to employee.age and add day of year, date of birth, okay? And I can write it as setters and getters for that one. As soon as I do this, both salaried employee and the hourly employee will have this day of year properties, okay? If I do this set day of year and get day of year thing, okay? If I do that, my UML diagram will look like this, okay? I am going to say day of year is part of this class, but see this diamond? Diamond means composition. Well, there are a few diamonds, but we are going to see it as just a single diamond now. There are different types of diamonds, and you are going to see them next semester or other year, I don't know. So I am saying that employee class has an instance of day of year class. So we know this is a composition. And this relationship is called has a relationship. Composition has a relationship, okay? Inheritance is a relationship, okay? The distinction is very important. They are both very nice ways of software reuse, code reuse, examples of code reuse, okay? But inheritance is definitely different than composition. With the inheritance, there is a relationship. Why do I keep saying is a relationship? Because each salaried employee object is an employee object. Compiler knows about Compiler knows about this too. Okay? Compiler knows that each salaried object is an employee object. Why? Why do I keep saying this? Because if a function expects an employee object, you can send a salaried object to that function because there is an is a relationship between them. The same thing, if a function expects an employee object or pointer, it is okay to send an hourly employee pointer or reference or function or the object itself to that function. Compiler knows about it. Compiler knows this is a relationship. Of course, has a relationship is different. Has a doesn't mean that day of year is an employee, right? It is not an employee, but employee has an object of day of year class, okay? But they are all nice. I have implemented many things for employee. Let's say employee is a complicated class, yes. Okay, it is not, but let's say it's a complicated class. I tested it thoroughly. I like it a lot. Now I am adding more functionality to it without any worries about the employee side of it because I know that it works. The same thing, I designed, tested, implemented this day of year class. It is a very complicated class, but it is very easy to use. Through composition, I am using it in my employee class. And in fact, I did the same thing for the string class. Remember? String class is a very nice class, very easy to use, but it's a complicated class. But I get rid of that complication. I abstracted away that complication by just using this composition principle, or has a principle in my employee class. Okay, so what did we say at the beginning of the semester? Whatever you can do with C++, you can do the same thing with C, no problems. I am not going to tell you anything that is not possible with C. At the end, after all of these C or C++ or Java statements, they all will be translated to assembly lines, right? So there shouldn't be any difference between those. So what is the advantage of C++? C++ will tell you ways of achieving this software reuse, or better software design, or better software maintenance, okay? If you follow those, then you take advantage of object-oriented programming principles and object-oriented programming languages. If you don't follow them, okay, that means that you don't know object-oriented programming. You are not using object-oriented programming principles. Basically, you are maybe a C programmer or something else. Okay, and these are some examples of, again, object-oriented programming principles, inheritance and composition. And what is inheritance? Inheritance is assuming that I have this functionality in this class, assume that I accept all that capability, I like them, but I need to add some more capability, like salary the employee, I say that I need this salary thing, get salary, set salary. For the hourly employee, I need to add this set hour and get hour thing, okay? And I can continue and I add many things to this hierarchy, okay? Many things to this hierarchy. And it's a classical example to show the standard Java collections hierarchy. Okay, Java collections hierarchy is like, this is Java's standard template library or standard library. Let me show you the Java collections hierarchy. Well, it is, okay. Maybe this one is better. Yeah, okay, let's see this one. I didn't tell you, I mean, there are different types of things in this hierarchy. Can I make this like full screen? Yeah, okay, good. Okay. So these are our classes at the bottom. This is a tree set. This is a set, okay, like küme in Turkish, but it is implemented using trees. This is a linked list. This is a vector. This is a stack, array list. As you see, they come from the same root, and we say that, as you see, tree set is actually a set here, okay? Sorted set is actually a set. List is a collection, and iterable is at the top. Iterable is a very simple, it is not a class, but we may think it as a class, okay? Very simple class. It just says that, okay, these are all, first of all, these are all containers. They contain elements, integers, doubles, or whatever, okay? This iterable is a very simple container. It just says that I can contain stuff, and you can iterate over the elements one by one, that's it. But this one says that, this vector one says that, okay, I am an iterable, I contain stuff, but since I am a vector, you can access the elements one by one using my indexing mechanism. Remember indexing mechanism? I am going to give you that. This one says that I am a priority queue. It's like it's a queue, but okay, it's a queue, but you can assign priorities to the elements and etc. As you see, many things are common, okay, for these elements. I don't know where it got, okay, can I do this? Okay, another hierarchy, map hierarchy. Many things are common between these classes. Common things are collected at the top. You specify your differences between the top classes. This hash table and hash map and tree map, they are all maps. Whatever I have inside a map, they are all common to each other, but they behave differently in certain aspects. Okay, so it's a classical example of class hierarchy that comes from Java. The Java language is designed this way from the beginning. Okay, C++ is not designed like that, the standard template library like that. So I am not going to give you any nice standard C++ hierarchy pictures. Well, you can have your own container classes like that, but I am not going to give you an example like that because it is not standard. But you got the idea, yes. Okay, so let's go back to our driver code. Driver code says that I am including hourly employee and the salaried employee. Okay, hourly employee and the salaried employee. Since we have our own namespace, I am going to using declarations. Okay, hourly employee and salaried employee. Here is an hourly employee, Joe. Joe, I can set name. See, set name, set SSN. It comes from the employee class. If you look at the hourly employee classes function members, you don't see any set name, set SSN, right? I have inherited it from the employee class, right? So I can use it the way I want, like my functions. I set them, and set rate and set hours are two things that I have defined, nearly defined in hourly employee. And now I can use them, get name, get hours. And print check is something that I have redefined, okay? This is redefined. Let me go to hourly employee. Hourly employee says that I am going to redefine print check. And let's go to the implementation. Implementation file is just 60 lines of code. Employee CPP is 60 lines of code, really. But I did not repeat anything inside this employee in my hourly employee. So instead of this hourly employee being 120 lines long, it is just 60 lines long. Let's look at this print check. Print check says that, okay, I am going to set my net pay. Again, set net pay is inherited from employee class to this value. And it is interesting. It says that call employee print check. Okay. Employee print check, whatever it is, I guess employee print check prints the name of the person, SSN of the person, right? After that, on top of it, I am printing these. Okay? So I am redefining the print check of employee. Okay? I am redefining the print check of the employee. But on top of it, I am putting this stuff. Okay? I am calling the print check of employee, and I am adding more stuff to it. What does this look like, line 50? It looks like I am calling what? A static function, right? But print check is not a static function. Okay? So what does that mean? Whenever you see such a notation, it doesn't automatically mean that it's a static function. It might be a function from a class that you have inherited. Okay? So this is my print check. Let's go back to the driver code. I call the print check and I'm done. And then salary the employee is the name, social security number. I think this is the third parameter is the salary, right? And get name works and the print check works. It just works. Okay. And as you see, I am not including the employee.h in here. Why? Because this one already includes an employee in it. And by the way, I don't have an employee objects in that driver code. I don't have any employee objects. Okay, that's basically the whole idea of inheritance. Okay, mechanism is very simple. I mean, in terms of how you play with the inheritance in terms of syntax, all you do is this. I am an employee. Okay, this if you read this in English, hourly employees and class, it's an employee class, but I'm going to add more features to it, and the some places that I don't like, I'm going to change it. That's how you read this line. That's how you read this line. Okay, let's go back to my slides and let's do some definitions. Okay, let's read this green stuff. This class is called a base class. Okay, and this process is derivation. You are driving, okay, you are driving a new class, derivation. This process is inheritance process. This is composition, right? So this is a derived class. This is another derived class. This is the base class. Okay, these are C++ terminology, and we use it that way. It's like, you know, in mathematics and calculus we have derivatives, right? Türev, türetilmiş sınıf, temel sınıf in Turkish. Bu işlemde türetme işlemi, sınıf türetme. Türev gibi, yani türeve de diyoruz, derivation. Derived, okay, derivation and derived classes, and this is the base class. Good. Any questions on this? And here's a mechanism, and has a mechanism is, we already discussed that. Again, let's talk about this is a relationship. What did I say? Every salaried employee is actually an employee. Every hourly employee is actually an employee, but the relationship between these two is not like that. There is no is a relationship between these two, right? I can't say an hourly employee is actually a salaried employee, right? So the picture might look like this. Employee objects are in a large set, employee object set. Inside this employee object set, there is salaried employee objects, a subset, and hourly employee objects, another subset. Okay, two subsets inside this employee object. So what does that mean? Every salaried employee is actually an employee. Every hourly employee is an employee object, but not all employee objects are salaried employee objects or the hourly employee objects. Okay, so this is the hierarchy. So employee is the most general class. Okay, it has many more. It may contain many more elements than salaried employee and hourly employee classes. It is much more general. Salaried employee and hourly employee classes are more specific. Okay, more specific. And we reflect this idea in our code. We say that employee is a general class. You define your general rules inside this employee class, and you derive your specific classes from this employee class. Employee contains the common code between the salaried employee and the hourly employee. Okay, what are those features? Setting name, getting name, setting social security number, getting social security number, etc. Okay, so employee contains the common code between these two classes. Like here, map contains the common code, common features, common interfaces of all these classes. Okay, so this prevents code repetition, code duplication, copy and paste thing. Okay, and it is easy to understand the relationship between the classes. So what is the difference between a hash table and a hash map? You know that both of them are maps. Okay, that's the common thing. For the differences, you just look at their interfaces. Okay, good. So let's move on. Let's go to our code and see how we implement stuff from employee age. Let's go to hourly employee .cpp. Hourly employee does this. It says that my constructor hourly employee, okay. Well, I know that I am an employee, right? The first thing is that I do, since I am an employee, I call the constructor of the employee. Okay, this is how you call it. Then I set my wage to 0, wage rate to 0, and hours to 0. Okay. Deep inside it, hourly employee, there is an employee object, and I initialize it. If I am using this interface, make it a little bit smaller so that we can see it. If I am using this interface, okay, this interface, I get the name, I get the social security number, I get the rate, I get the hours. Now I'm going to use them. Well, these two, okay, name and the number, they belong to the employee. So I call the employee classes my base classes constructor that takes 2 parameters. I send it to them. Okay. Then for the others, I need to do something myself. I set my wage and I set my hours. Okay. So it is the member initialization position member initialization syntax, and this is how it is done. So this is interesting here. This one. This is how you initialize your base classes data. You don't care what kind of data it keeps. You don't care how it keeps it. Okay. All I know is that this is how I initialize it. Okay. Somebody later can change the definition of employee. They might decide to use, instead of strings, let's keep the name using the character arrays. I don't care. I'm going to use the same interface. Implementation might change in my base class. And then I have my set rate. I get this number and assign it. Get rate is a getter. Hours worked. And this one is a getter. And print check, as we saw before, set net pay, and I set it. And I call the employee print check. Then I do this. Okay, syntax wise, what did we do in our class definition? I said that I am an employee. In my implementation, I showed you how you call your base classes constructors, so that your base class part, the stuff that you have inherited is initialized properly. Okay, and other than that, this is how you call the base classes function in a redefined function. Okay.
Is this a common code?
No, this is the specialized code. This is the code of hourly employee. Hourly employee. This is the implementation of hourly employee. Common code is from employee H, employee CPP. Okay. By the way, this print check is not correct. I think I am showing you a different version of this thing. Can I do this? No. Do I have another employee? I think I modified it from last year and I forget to not save it. Let me change this. So I am going to comment this out. Yeah, let me comment it out. Comment it out. And I think I am going to say cout employee name and get name, right? And after that, end of line. Then what am I going to do? I think I am going to print SSN. employee SSN, get SSN. That's it. Okay? So this is what I do in print check.
What about salary? For example, for the salaried employee, we will just write the salary, but for the hours employee, we have to multiply it by the hours and the wage.
Let's look at their print check implementation. Hourly employee print check is this. Okay, I set the net pay hours times wage rate. Okay, this is how much I'm going to pay you if you are an hourly employee. But if you are a salaried employee, I am going to say, okay, your net pay is the salary, so your weekly salary. Okay.
We define them separately.
What?
We define them separately.
Sure, well, but they are different classes and they behave differently. I mean, how you pay your hourly employee and salaried employees are two completely different things.
Yeah.
They are very, very different. Okay. They are very, very different. And this behavior is not common. This behavior is not common in the base class. Okay. So, question for you. If this print check behavior is not common in the base class, why do I have a print check function in the base class? I mean, remember what I said? You keep the common code between these two classes in the base class, right? When you derive from them, when you inherit from them, you automatically inherit that common code. But it looks like print check is not common between those two, right? Why do I write this print check in my employee then? I mean, this one can have a print check its own because it's very different than hourly employee. An hourly employee will have its own. Employee print check doesn't do anything. I mean, remember what I did before? It was exit one. So why do I write print check in my employee? Was it a mistake? The answer is no, of course. Why do I have print check in the employee class? See what kind of things this object-oriented programming principle makes you think. I mean, this discussion that we are doing right now is completely meaningless in C. But if the language forces you to collect the common functionality, common code in some class, okay, that means what? It is forcing you to eliminate code duplication. It is forcing you to write general code that can be reused later. So okay, let's go back to the question again. Why do I have this print check in my employee class? Yes?
Because salaried employee and hourly employee get print check from employee.
Because salaried employee and hourly employee gets printed from employee. I don't understand what you're...
Print check function
Yeah.
from employee.
Yeah, but I am not inheriting anything, right? I don't like it. I am redefining it. Instead of redefining it, why don't I define a new function like print check here and print check here? Because I didn't inherit it, right? I am saying that I am going to redefine you. I don't like how you behave.
To make the print function signature same for both classes.
Yeah, a very good point. You understand? Say it louder.
To make the print function signature same for the both drivers.
Yeah, you are forcing both of these salaried employee and hourly employee to have a print check function. I mean, if you are going to be an employee, then either you have to take this implementation and accept it, or you redefine them. In both cases, you will have a print check function with exactly the same signature. So you are forcing them to have the same print check function. That's one thing. The other thing is, remember, even though the print check function is not exactly valid for salaried employee or hourly employee, remember how I implemented my print check function for the hourly employee? I call the base class as half implemented print check function. Employee's print check function is not good for me, but it is still useful, okay? It's not exactly right, but still I can use it partially. I do my set pay. Okay, after that I call the print check. Then on top of it, I print my wage rate and hours, etc. And I think I can do the same thing in hourly employee, in salaried employee. Let's go to salaried employee. And I think it is get name, get pay. Yeah. Instead of these two lines, I am going to let me get rid of these two lines. Okay. Comment them out and call employee print check. Oh, maybe do it this way, right? Control delete. Okay. And unfortunately, I saved it. Okay, that's the problem for next year's students. Okay, so it is still useful, even though I am going to redefine it. It is still useful, and the other thing is that's really what our classmate said. I am forcing these classes. Okay, to have this print check function. You have to have it. If you don't like it, redefine it. If you like it, it is yours. Remember this hierarchy, this class hierarchy. What is the difference between this oval shape and the rectangular shape? Rectangular shape classes are regular classes. This one is called an interface in Java. As you see, it's an interface. Interface means what? It's a very interesting class. Interface is a class that defines only the function signatures and it doesn't implement them. So inside this interface, there is nothing implemented. You cannot implement it, okay? Java will not let you implement anything inside an interface. So, I mean, if I am not implementing anything, why am I inheriting? You are inheriting the interface, right? You are inheriting the function signatures. So if you are in hash map, you have to implement all of those functions one by one. Okay? The inherited thing is the function signatures, the function interfaces. That's why this is called an interface. Okay, we will see that in Java when we look at Java. Okay? Good. What else I can tell you? Multiple inheritance is, well, let's look at this. In real life, people like using hierarchies a lot. We like to think about our objects, our concepts in a hierarchy. Like we would say, a motor vehicle, motorlu taşıt, okay, is a class. Automobile is derived from motor vehicle, is a specialized motor vehicle, okay. Motorcycle is a specialized motor vehicle. Convertible automobile is a special type of automobile, but all three of them are motor vehicles. So what would you put in a motor vehicle? A motor vehicle should have an engine, right? It should have a registration plate. It should have an owner, right? That kind of stuff. But how many wheels does a motor vehicle have? I don't know. It depends on the type. Motorcycle has 2 wheels. Automobile has 4 wheels. A semi-truck has 16 wheels or something like that. Okay? So I cannot specify some things in motor vehicle class, but when I get specific now, I can tell you this one has 4 doors and this one has maybe sometimes 2 doors. This one doesn't have any doors at all, etc. Okay, good. So you are going to see this kind of hierarchy. In biology, you are going to see it. In mechanical world, you are going to see it. In computers, you are going to see it. What kind of computers? I have a computer class. I have mainframe computers. I have server computers. I have the PCs. I have the deriving from the PCs. I have the laptop computers. Deriving from the PCs, I have the tablets. What would you call a a cell phone. Okay, okay. This is a computer class, computer. I think personal computer is like that. From the personal computer, maybe I have the portables, right? Portables like laptops. Portables. From the portables, I drive maybe the laptops and maybe is tablet a laptop or a portable? I think the tablet is a laptop, right? Tablet. And maybe a portable computer, your cell phone computers, etc. So if I want to, I can generalize this hierarchy and add more stuff to it and later change it maybe. This kind of thinking is common to human thinking, okay? We like to compare, we like to categorize our objects in hierarchies, sometimes in sets. This is a subgroup of this one, okay? Computer is at the top. What is the common thing between all the computers? What kind of CPU it has and what kind of memory it has, right? CPU and the memory are two things that a computer cannot exist without a CPU or the processor. And what's going on with my eyes? Is there dust somewhere? Let me open that. Okay. That will fix it. Maybe I can say what kind of processor you have and what kind of memory you have. Then after that, of course, with the computers, there are mainframes, and there are other type of computers, etc. So when you come to PC is usually a smaller thing. I don't know how you differentiate between these two. But as I said, people like developing this kind of hierarchies, and the same thing with the software classes. We like to compare our classes like that, and this way I can collect all the common functionalities at the top classes. Okay, at the top classes. Good?
Can I ask a question?
Sure.
By defining the print check function in the common code, we are expressing that the print check is CPU, for example, for this.
Kind of, yeah. We don't know what kind of CPU it is, but you have to have a CPU.
You have to have.
Yeah, you have to have a CPU.
Okay.
C++ or Java or any object-oriented language, sometimes I can do this. I am not going to show you the full details of it. Let's go to this employee age. Sometimes I can do things like very interesting stuff here. Okay. You do this equal to 0. This is not assignment. What does that mean? You are assigning a 0 to a function. It means that I am not going to implement this print check. Okay. Employee class should have a printf function, but it is not going to be implemented in this class employee. These are called well, I mean, this notation is exact. Okay, these are called pure virtual functions or abstract functions. Okay, abstract functions. And in abstract functions, you are saying that what's an abstract function? It has the signature, it has its definition, it has header. Okay, but it doesn't have the implementation. So if you are deriving from employee, now you have to have an implementation. Okay, you have to have a print check function and then you have to implement it. Because I am not going to, you cannot call it from the base class because it doesn't have an implementation. And if you have such a function in your class, employee class, then what kind of an employee object, what kind of objects are employee objects actually? You cannot call some of the functions. That's why compiler will not let you make an object of this employee class, because it says that, well, employee class is such a class that some of the functions are not implemented, so I'm not going to make any object of the employee class. So we call this employee class an abstract class. Remember this hierarchy? These are abstract classes. So in abstract classes, there are some functions are not implemented. This is an interface. No functions are implemented. These are concrete classes. Everything has to be implemented. Okay? No objects of interfaces or abstract classes can be instantiated. Okay? Don't get confused about this human inheritance and the object-oriented programming world inheritance. The kalıtım, the word kalıtım or miras, well, it is used that way, but I mean they are not exactly the same thing, because in human inheritance, if there is inheritance going on somewhere, somebody has died, right? That's a bad thing. Okay? In software object-oriented programming world inheritance, when you inherit from an employee class doesn't die. It continues living, right? I can make objects of it. I am still using it. Hourly employee inherits from employee. This one still, okay, exists. And these two, they don't share the properties of this one, okay? They keep copies of it, okay? I can inherit from the same base class as many times as I like. The salaried employee doesn't know that hourly employee inherits from employee, right? Salaried employee doesn't know that somebody else is inheriting from employee. Sometimes this relationship is called, okay, this is the ancestor, this is the descendant. Bu bunun atası da bunun torunu gibi düşünün, ceddi. They don't know their brothers or sisters, something like that, okay? Parent class, child class, parent class, child class, but this one doesn't know that there are siblings of it. Okay, so human inheritance and the object-oriented programming world inheritance, although unfortunately we use the same term for both of them, they are very, very different. Nobody is dying in the software world, okay? Inheritance is, I mean, in human inheritance, there are good things and bad things. The good thing is, well, I got money, right? That's good. But the bad thing is somebody has died, okay? In software world, it is always, nobody dies and I got lots of stuff. Good. Any questions? Any more questions? I kept talking and talking and talking. I kept talking for 50 minutes, and I think I talked about it maybe 20 minutes in the last lecture. All I showed you as the syntax difference is this line, right? So that's what we do in object-oriented programming. We just talk. I mean, I talk, you write, and I gave you grades, and half of you will fail. More than half of you will fail, it looks like. Nobody is responding. Nobody is answering my questions. Nobody is asking questions. Okay? Not going good. Let's take 10 minutes of break. After the break, we will continue.
Şunu burada unutmuşum da.
Efendim?
Şunu burada unutmuşum da.
Tamam, olabilir. Hocam ben yoklamaya imza atmayı unutmuşum da. Tekrar atabilir miyim? Hayır. Onlar niye gelmedi oradan ya?
Bu nasıl bir koku ben anlamadım. Açıklar mısın? Bu kokunun kaynağı nedir? Hala
Gelenleri diyorum.
yani ihtiyacı var. Az çok da bizim boş iş böyle.
Öyle kanka. Onu buradan alalım.
Ama uyuyacağım. Ben bir ondan kalmadım.
Ben kaldım. Bir de var.
Gözün yanıyor.
Uysam uyuduğumu söylerim. Vallahi.
Bak benim uyuyor.
Kalkacağım. Uyuyacağım onu.
Dışarı çıkmıyor. Burası harbi danslı da.
Gelmiş mi?
Bugün mü? Evet.
Ya sen günahımı al, sen günahımı al.
Hadi gel şey ısmarlayalım.
Aa geleceğim. Tam size söyleyeyim.
Ben sıraya giriyorum. Ben de geliyorum.
İçim geçti ya. Çok kötü içim geçti. Nokta seçiyorsun ya.
Harbi öyle yazmış.
Evet. Fikret çok kimse yapamıyor. Keyif de. Keyif de.
Fit, can fit, make fit. Best fit.
Konu ne?
Öder.
Yine mi seçtisi bize?
Hayır abi bunu ilk ödede verseydi daha fazla değil miydi abi? Olur falan. Bildiğin şeyi yaptırdı yani.
Bize interface verecekti. Evet. Ana klası verecekti. Oradan böyle şeyler yapmışlar.
Bakalım ya. Sörkütçü cevaplar
Sonra
atmış.
fonksiyon tamamlama yapacağız.
Sörkütçü cevaplar atmış. Var mı?
Oğlum bakmayın lan bunu. Ayağım bakma. Daha ayrı sor. Yapma.
Ne olacak ya? Kanka 4-0-4 çıkıyormuş. Böyle bir şey hayatta bulmadım.
Hatırlamıyorum. Bir an ben iş yaptım sana. Sor.
Ben buldum bunu.
Eğenmek için.
Sörküt.
3 E. 3 E.
Dosyalar.
Bakma. Sessiz söyle. Ben bakmadım.
Aynen kanka sessiz söylemedim.
Sorduğu
Sen şeye baktın mı? YKS'ye girdikten sonra şeyler açıklanıyor. Sen bak.
İyi bekliyorlar.
Ben baktım sen de bak. YKS açıklandıktan sonra TT çok yani çok
Hayal.
YKS sen de bak.
abi.
YKS açıklandıktan sonra baktın mı?
Hayalini çözdün oğlum. Nasıl bir şey? Ya
Ama hayır gösterme. Bak hiçbir süre bakmak istemiyorum.
oğlum bir şey göstermiyor.
Ben oğlum solution'ları gösteriyorum.
Ya oğlum çalışma lan.
Şimdi yanlış elim kayacak. Ben göreceğim. Sen bana kim bulacak? Ben nasıl çalışacağım?
İşte internet canım.
Evet. Olmaz.
Oğlum
40 lirada 0 aldım.
November 18 2021 basmış. Kalem önce.
Dolaracağım. Konuşma süresi istiyorsan. Şeyi nasıl göstereyim? Ben bitti galiba basıyor. Sen nasıl? Aa. Devam ediyor ya. Sallamaz abi.
Aha. Bunu ben 98 90 ne bulmuş inşallah doğru verdim.
Kus oğlum ya. Sayı söyleme ya.
Tamam bir tane doğru gibi var.
Oğlum içinden konuş. Sayı söylemiştim. Az önce
Aha.
uyardık ama.
Üçüncü soru doğru.
Oğlum sana böyle de. Böyle de sayı verme.
Ama sayı vermiyor.
Ulan bakacağım.
Üçüncü soru doğru beyler. İyi 20 puanı aldım.
Bir şey var abi.
Oğlum meşle Martız çözebilmiş ama helal. Kardeşim şunu bana verir misin? Kupamı verir misin? Ver kupamı. Ver abi. 20 puan aldım. 20 puan aldım. Aynen sen. O sınav günü ne yedik kanka? Bu H, I çarpı R olarak.
Ya oğlum ben de öyle yaptım. Sonra düzelttim onu. Yarım saat. Mantıklı uğraştım.
Doğru söylüyorsun ya. Bak. Ağlayacağım.
O videoyu bak.
Hadi 20'yi aldım. Yirmi garanti 40 belki.
Son ne?
Oğlum bir şey yok bakın ben. Dedi iki
Evet,
soru yap.
takas yapalım mı? Takas yapalım mı?
Mehmet sakalları kessin olacaktı abi. Mehmet böyle olur ama.
Hangisine çok iyi biliyorsun?
Vallahi yaşamıyorlar. Öyle oluyor yani. Çok çirkin oluyor lan. Bende yok abi bir şey. Sakar yani. Çirkinliğini saklar.
İki arada kahvede güzel gidiyorum. Konuşalım. Sakal.
Öğretmen oldu.
Çözmüş ya.
Abdullah konuşma Abdullah.
Ya oğlum ne olacak? Ben de sen gibiyim abi.
Ben de sen gibiydim kardeşim.
Korkun nedeni faydası yok oğlum. 1, 3, 1, 4, 5 yok.
Kaybedersek çalışalım.
Kardeşim bugün yaptım. Bekliyorum. Kanka bu akşam 5 liraya bekledim.
Nasip olursa.
Okay, so let's look at these definitions. Let's say I have two declarations. One is an employee declaration. E2, the name is Ali and the social security number is this. And I have the salary, the employee S1, name is Aisha and the social security number, and this is the salary. I like to see what's happening in the memory. For the employee, it is easy. For the employee, the picture is simply this. Okay. I will have 3 data members in it, right? A name string, SSN, and I think double net pay or something like that. This is E2. This is how it looks. But how about this S1? S1 is something like that, okay? Inside S1, there is an employee object, okay? You have to keep that employee data somewhere, right? Where am I going to keep it? Of course, it is in S1, okay? It is in S1, and inside S1, there is an employee object, and that employee has a name and social security and net pay, and there is a salary, double salary, right? So that's what happens. So it looks very much like composition, right? In terms of how you use the memory, it looks very much like composition. And but the compiler sees it as inheritance is a relationship, and we can take advantage of this is a relationship by just writing less code. And as I said before, since the compiler knows that there is an is-a relationship between this employee and salaried employee, whenever somebody needs it, whenever somebody needs an employee object, I can send an salaried employee object too, because there is an is-a relationship. By the way, this relationship is not symmetric. Okay, every salaried employee object is an employee object, but the opposite is not true. Okay, not every salaried employee is an employee. Sorry, just the opposite. Every salaried employee is an employee, but not every employee is a salaried employee. Yeah.
If employee class has a relationship in another class, salaried employee can use it.
If employee, okay, in this case it has it. Employee has a relationship with the string class, then ask your question again.
I mean, if inheritance like,
Is a relationship?
yep.
Well, is different than has a. Composition has a relationship and it is different than is a relationship. It's both nice ways of software reuse, okay, using the software code reuse, but they are different. Their concepts are very different. In the is a relationship, there is this hierarchy. Has a relationship is containment, okay. We have been using has a relationship from the first day of the class, right? We have included integers in our classes. Integer is a class. Day of year is a class, right? We have been using this integer as a data member in our class. So we have been using composition all along. Now I have introduced another way of interacting two classes together is a relationship. Is a doesn't mean has a doesn't mean is a. They are two different things. Can they happen at the same time? Yes. If you force it, yeah. I mean, you can force to have is a relationship and has a relationship between two classes at the same time. Would that be meaningful? Well, it depends. Maybe we are going to see some examples of it. Okay, good. Any other questions? So this is how the memory works. We looked at it. Let's move on. Okay. General form of class is defined. You understand what I mean by this, right? Okay. Remember the Java hierarchy? Set is the küme, Turkish. Set is the general form of the class. Okay. Then you have the sorted set and the tree set. There are two different implementations of the set interface. Sorted set keeps all the elements in a sorted way. Well, usually you don't care about the sortedness in a set, but this one is a sorted set, keeps its element in a sorted way. This tree set uses some kind of other implementation to keep a set, okay? But the common functionality is here, so this is the more generic class, So this way of designing your software makes you think that what are the common functionalities? What should I keep as common code between the classes? If you collect all the common code under the same class, okay, that means what? You are going to write less code, you are going to test less code, and that code will be a reusable code, right? Since it is common between many classes, it will be a reusable thing. So this inheritance thing or the composition thing are both ways of forcing you to think about keeping the common functionalities, keeping the common code under the same name and keep reusing it over and over again. So general form of the class is defined first, and then I do the specialized version, specialized set. And if this function f needs a set reference, okay, set reference, then you may send a sorted set or the tree set to this function because there is an is a relationship between them. Compiler knows about it. Okay. Don't forget about the attendance. I think it has started. Specialized versions then inherit properties of the general class, and you can add features to the general class or modify its functionality if you don't like it. We talked about this yesterday. And a new class inherited from another class. That class is called the base class that you are inheriting from. The derived class is a new class. Automatically base classes, member variables, and member functions, everything is inherited, okay? And we can then add additional member variables or additional member functions, public or private, doesn't matter, or we can derive them. Okay, so this is a very actually flexible mechanism. I can use it in many ways that I want. Let's look at this one. I don't know what I was thinking while okay. Remember I had the day of year class? I mean, day of year is simple enough. Why are we developing a hierarchy for that? But let's look at this implementation. Okay, I have a non-mutable day of year class. Let me write it more in a more readable way. This is non-mutable. Mutable means modifiable. Non-mutable, non-modifiable. Okay, non-mutable day of year. And this is mutable day of year or just day of year, right? Day of year. Non-mutable day of year has, of course, day and month in it. Okay. In my constructor, I have day and month, and I have only the getters. Since this is non-mutable, there are no functions to modify this day and month. Okay. So this is like a constant day of year class, right? But there is no way that I can modify this day and month. Okay. But then if I need to modify these day and month data members, I cannot use this class. I am going to derive another class here, day of year class. This one will have setters and getters. Okay, I can set the day and the month. I can modify it. So what kind of things I can do with this hierarchy? The hierarchy is this. Let's say I have a function, print function. This print function is supposed to, okay, this print function print day of year. This print function is supposed to take a day of year and print it. Which one would you use as your parameter? Non-mutable day of year or day of year for this function? Which one? Non-mutable, of course. Why? Because print day will not modify anything in this object, right? So let's make it, okay, non-mutable day of year reference, okay, object, and it does whatever it needs to do. Okay, let's say I like to print this day of year object somewhere. I can call this function easily, no problems, because there is a relationship. Doesn't matter if I have a non-mutable day of year object or day of year object, this function will work on them. So it looks like I don't need the const keyword for those functions, right? This is what I did, right, actually. These are my const functions. These are my non-const functions, right? So I didn't need any const keywords for those functions, but I can achieve whatever the const can do. Why? Because I cannot modify anything on objects of this class, non-mutable day of year. I cannot modify. Since this print day of year receives a non-mutable day of year object, I know that this print day of year will not modify my object, whatever the object is. Okay? So, I mean, how many times and how many minutes or how many hours I talk about the const keyword in C++? Well, I could have done the same effect. I could have get the same effect using this inheritance mechanism. In fact, in Java, you don't have const keywords. I mean, the const keyword of Java is not the same as C++. It's different. They don't have function const functions. They use this mechanism to achieve the same nice property, same nice principle of least privilege rule. Okay? So inheritance is, as I said, is very flexible. You can use it for these kind of purposes, and it's very common. Which one is more generic? Okay, non-mutable class or mutable class? This is more general. Okay, this is more general. I can. Okay, this is non-mutable class, and this is mutable class. I can use the mutable class objects as non-mutable class objects, because if I don't modify them, I am not modifying it. But opposite is not true, okay? You cannot use a non-mutable class object as a mutable object, right? This is how I modeled it. I mean, I am not saying that it should be this way. I mean, there are things occurring outside of my world. I am modeling them in my head. This is how I modeled that, and as long as this works, then it's a good model, good enough model. Yeah, somebody was asking a question. Hi, yeah.
You don't have to put a const there, but should we put a const?
In C++, you mean?
Yeah.
Well, I mean, well, in C++, if you are developing this hierarchy just to show that you don't need a const in there, then you are making a mistake. Just use a const. Don't write a C++ hierarchy like this to achieve the whatever const can achieve. That's why, I mean, of course you should use const wherever it is applicable. So you shouldn't write such an hierarchy, okay? This is just an example. So, I mean, constants and non-constants is, I mean, you are saying that I have a class and some of the class objects will be constant objects, some of them will not be constant objects. So the const is kind of a modifier, it's like an adjective, right? Sıfat gibi şeylerin, objelerin başına getiriyorsun. Const objeler, non-const objeler gibi. So C++ says that I am going to give you a mechanism for the functions that will work on the const objects and non-const objects, okay? So it's a way of classifying your objects into two classes. And this hierarchy says that being const and non-const is just one way of classifying your objects. How about being green objects and red objects, okay? Object type 1, object type 2, object type 3 kind of stuff. So if you have those kind of classifications among your objects, then use this hierarchy stuff. That's what I'm saying, yes.
We don't use any const keyword in here, right?
In this hierarchy?
Yes.
Well, that's what he was asking. Well, I mean, C++ says that, I am saying that, whenever the const needs to be used, use it, okay? I didn't develop this hierarchy to eliminate the const keyword in C++. All I am saying is that you can use this kind of stuff to get the same kind of effect. Don't use this hierarchy, this kind of hierarchy, to eliminate the const keyword. Use const keyword wherever it is needed.
Compiler won't give any error
If you don't use the const keyword,
like this if we use this hierarchy.
if you, well, yes, you will get here. If you say O dot set day 10, is this a compiler error? Yes. What is the compiler error? What is the compiler error?
It is not mutable. And we are
O,
set it.
the non-mutable day of your class doesn't have a function named set day, right? That's the compiler error. It is not like this is a const object and you are calling that a non-const thing, right?
But if we say day assigned to 10,
What?
day assigned to 10.
I can't do that. How are we going to do that? It's a day and month are my private data members.
But we can use in implementations our private data members.
You mean inside the day of year? Of course, in your implementation, a non-mutable day of year or day of year, you can do whatever you want to your private data. But this print day function is not a member of this class or this class. Okay? Remember, the constants only valid for the customers of your code, right? Okay, so this is an error. So don't think inheritance as just simple commonality and deriving from it. If you think it originally, you can find many uses of inheritance. As I said, Java is very similar to C++ because Java is designed by people who know C++ very well. They are experts of it, right? And they said that I am going to be different from C++ in this way and this way. If it is the same thing, then they use exactly the same keyword. The class keyword is there, public keyword and private keyword is there. Okay, so they have exactly the same meaning, but the const keyword is not there in Java because they are using const in a different way. Okay, and a const function, there is no const function in Java. They don't do it. Okay, good. Derived classes. Okay. We talked about this. I'm going to skip. Okay. This slide says that I did not implement design employee to use its objects. Okay. Employee object doesn't mean anything. Okay. For as an employer, okay, as an employer, I don't need employee objects. I need salaried employee or hourly employee or commission employee or whatever. Okay. So that's what I need. So why did I develop this employee class? I developed the employee class so that I can derive other classes from it. I use this employee class to collect, okay, the common functions, common data under the same class so that for the other classes I can derive so that I can prevent code duplication, code repetition. That's why I need employee class. So we won't have objects of this class. I did not develop it to have objects of that class. That's weird, right? You have a class, but you are not supposed to use objects of that class. So why should I have such a class? Well, that class is good as a base class. Okay, that class is good as a base class, and I am going to derive new classes, and that class is going to be useful as the base class. I think we did this before. If I have a class like this, class A, and in my private section of the class, I have my constructor. Nobody can make objects of this class, right? Because the constructor is private. Such a weird class. Why would I have such a class? Well, you are telling everybody that I don't want you to make objects of this class. Okay, maybe I'm going to use it as a base class to the other classes, and it will be useful for as base class. Okay. Okay. So such classes exist. You are not supposed to make objects of it. Okay, we talked about this one. Good. Deriving from base class employee, automatically we'll have all member variables. Automatically we have all member functions. Remember inside the salaried employee there is an employee. Okay, when you make a salaried employee, you make an employee. It looks like very much like composition. Of course it is not. Okay, so automatically I have all the member variables, automatically I have all the member functions. Okay, so derived class is said to inherit members from the base class. Okay, we already talked about this. Print check is redefined. Okay, for some reason, I don't know why, yesterday somebody asked it. Okay, what is this public? What are we going to do with this? Well, let's ignore this public for now. Okay, but I have to have this. At the end of this chapter, I'm going to talk about what happens if I put a private in here or something else. But we are going to tell you that don't do that. Always put public in here. Okay, so you are saying that I am deriving myself from this employee. I am inheriting whatever the employee has. By the way, the class employee doesn't know that somebody is inheriting from him. Why did I call the class employee him? So we are trying to personalize stuff. Class employee doesn't know that somebody is inheriting from that class. Okay? Doesn't know that. The class employee code doesn't change at all, right? It is the same code. The fact that I am writing this hourly employee, I included this employee age, I inherited from class employee. I did not make any changes to my employee class. Employee class doesn't know somebody is inheriting from that class. Okay, so that's something good. That means what? That means I can write a class like this. Okay, you are going to like this. Not okay. If I write it in below, you are going to like it better. Class my vector. Okay, tell me what I'm going to write. Public, then std vector, let's say integer. What am I saying now? Right? What am I saying? My vect integer k, okay, std, you know what I am doing, right? Vector integer k. What am I doing?
We are getting the vector from the std into my vector class.
So why am I doing this? Because,
We are inheriting.
yeah, why am I doing this? Because I am going to do this. Okay? You remember integer vectors, they don't have the comparison operator, right? They don't have the less than, greater than. I am going to have my vector, integer vector, and it will be same as std vector, no difference, but on top of it, I am going to add this is equal to operator. Okay, so this is going to return true or false. Well, this is very nice, right? I mean, I know that vector is a very complicated class, but I don't care. I am saying that I am same as std vector, but on top of it, I am going to do this. My vector is like that now. If somebody later with C++ 21, C++ was 22, they modified this vector class and they added more capabilities, I will automatically get those capabilities, right? No problems. Good? Okay? So why all of a sudden I started talking about this? This class doesn't know that somebody is inheriting from it. Okay? Previously, I used vectors in my classes through composition. Now I'm using this vector through inheritance. Through inheritance. Well, this code may not compile, by the way, because there are ways of preventing other classes not inherit from you. You are saying that I am the final class, nobody is going to inherit from me. Okay, don't do that. You can do that. I am not sure if vector is doing that. If it's a final class, then I am not sure if it is that case, but the concept was, yes, you can do it. You can do it. Good. Any questions? By the way, I mean, these are relatives, right? These two are relatives. They are siblings. Where are those? Yeah, these two are relatives. They are siblings. I am going to. It's like the soap opera movies, right? Soap opera series. At the end of the first year of the movies, diziler var ya ilk yılın sonunda bir tane sürpriz çıkar ortaya. Bu bunun kardeşiymiş. I'm going to tell you, vectors and strings are siblings. They are related. Really. Did you know that? Did you see that movie? What you said that did you know that? Okay. Thank you for not spoiling it for us. You didn't tell us, and yeah, they are related, and I am going to show you later after the templates because you need to watch this movie a little bit more. So they are relatives. They behave kind of similar, but they are really relatives to each other. We will talk about them later. Yeah.
We said the inherited class have no idea if it is inherited or not, but in this case, does this employee class know?
No, it doesn't. Employee class doesn't know how many classes are inheriting from it. I'm not changing the employee class's code, right? Employee class is a generic class. Somebody has written this employee class 20 years ago, okay? somebody has, where is my employee? Somebody has implemented this employee class 20 years ago, and every year 2 or 3 people derive new classes from it. Employee class did not change for the last 20 years, so it's a very well written generic code, right? So software, best case of software. Do you know how we write Windows applications? You know how we write? This is not exactly correct, but I like to show it that way. There is a class named Windows application, WinApp. Okay, they had developed this like 30 years ago when they first introduced Windows. Okay, there is a class named WinApp. If you like to write a Windows application, you have to drive your class from this Windows app class. Okay, so this Windows app class says that if you are going to be a Windows application, you have to provide this function F1, F2, and F3, F4, etc. What are those functions? Maybe this F1 is close. This F2 is minimize. F3 is maximize. What else? What kind of functions should a Windows application have? Save maybe? Save all. This is close maybe, yeah. Well, all kinds of Windows applications. Let me open a Windows application. This is a Windows application, right? It has to have these buttons in the top right corner, right? That's the close, maximize, minimize, and etc. If you are going to be a Windows application, then you have to provide all those functions to me. Otherwise, you cannot be a Windows application. Okay? So there is a class named WinApp, and you have to drive yourself from WinApp. Otherwise, Windows operating system will not take you as an application, will not let you be part of the operating system. Okay, so inheritance used in that case too. We are going to talk about this example a lot, and all the graphical user interfaces are developed using this idea, this inheritance idea. Okay, if you are going to be a windowed application, an application with a window, okay, then you have to drive yourself from this class, and you have to provide this and this and this and this, etc. And I don't think that I will talk about graphical user interface programming using C, but I'm going to talk about it using Java, not because I like you to do graphical user interface programming. It is because it's a very nice example of how the hierarchies are used, how the hierarchies are implemented, how they are designed. It's a very good way to look at hierarchies. It's going to be in Java. Okay, good. Let's go back. Inheritance base class and write class, and we talked about these. These are the rules, and we talked about those. Write class, okay, don't need, well, we talked about that. We talked about those. Employee class, print check, I'm going to skip it. Okay, no, I talked about those. I am going to skip those. Hourly employee. Yeah, when I saw that, I was going to tell you that I wrote exactly the same thing last year. No, I wrote it today, right? Okay, so we know this. Hourly employee class additions, of course we can. Well, when I say I am going to draw this a lot, A and B. B inherits everything from A, everything, including constructors and everything. But A is, well, remember, if A has a function F1, now B has a function F1. It inherited it, F2, etc. A has a constructor, B inherits it, but it doesn't become the B's constructor because B is a different class. It needs its own constructor. And if you don't write a constructor for B, what happens? There's a default constructor, right? So, and that default constructor in itself, it calls the default constructor of this base class. That's what happens. So what I am saying is that even though you inherit the constructors of this class, you have to write your own constructor for B. If you don't write it, there is a default constructor. The same is true for the destructor, okay? A's destructor is not B's destructor, but it is inherited. Okay, so the rule of everything is inherited is valid, but the rule of its function, it becomes your function is true, regular functions, but this rule is not valid for constructor, destructors, and the assignment operators too. Okay, constructors, copy constructors, assignment operators, destructors, they are all inherited, but they don't become your constructors, copy constructors, assignment operators, and destructors. You need to be careful about those, and you need to implement them if they need to be implemented. Okay, so these kind of exceptions will happen all the time, you know. Okay, redefinition, we talked about them. Let's talk about some inheritance terminology. Okay, A is a parent class of B and C. Okay, A is the ancestor of E. Class is parent of a parent. A is an ancestor of E. What is the Turkish word for the ancestor? Atası. Dedesi. More than dedesi. Okay, A is an ancestor of it. B descends from A. E descends from A. E is a descendant of class A. D is a descendant of class A. B, C, E, D are A objects actually. B, C, D, E are A objects. There is a multiple inheritance here. Okay. There is a relationship between A and B, C. A is both B and C. A is both B and C. Okay, there is a multiple inheritance. It can happen in C++, not in Java, but in C++. You can say class A, column public A, public B. Okay, public B, public C. Okay, you can say that there is multiple inheritance. Well, there are many issues with the multiple inheritance. That's why Java doesn't do it. It makes the compiler a lot complicated and etc. There are other ways of achieving this effect too, but in C++ we support the multiple inheritance directly. Yeah.
Is B the ancestor of E?
B and C are siblings. They are not ancestors, or they are not this.
B and E.
B and C.
E. Echo.
Sure, yeah. I mean, of course. E is a child or descendant of B. B is the parent or the ancestor of E. This is just terminology. I mean, C++ doesn't know about parents, child, ancestor, and descendants, right? C++ knows about the base classes and the derived classes. Okay, good. So the constructors in derived classes, this sentence is not correct. Base class constructors are not inherited in derived classes. No, they are inherited, but they are inherited, but they don't become your constructors, right? They can be invoked within derived class constructors, which means that I inherited, I have access to it. Okay, so base class constructor must initialize all base class member variables, and since I have the base class in myself as a salaried employee, I have the employee in myself. I have to initialize those employee data fields, data members. So I'm going to use its constructor. So remember how we did it? Let's see how we did it. Employee, this is how we are doing it. So as a no parameter constructor of hourly employee, I am calling the no parameter constructor of the base class employee. Okay, here I am doing the same thing with the two parameter constructors. Okay, remember how we did the same thing with the composition? If I have a class object in my class, okay, I give the name of it and I put the parameters in it and I call its constructor. Remember how we did it? I think we did it with the day of year, right? We did it with the day of year. I don't remember where it was, but in the maybe third, fourth chapter, I don't know. Okay, we talked about this. Yeah, this picture is good. Hourly employee, let's say Ali Yilmaz, and this is the social security number, and this is the rate, and this is the number of hours worked. So when I make this hourly employee, this is, okay, this H1, of course for the H1, there is this rate and there is this hours, but in H1, hourly employee, there is this employee too, okay? So when I write this constructor, this part initializes the green part, employee name, the number, etc. And this part initializes the red part. So let me Control Z, and Control Z, right? And there is nothing else to be done. Okay. Any questions on this? Well, if you don't have questions, I will continue. Okay, this is the, what happens if you don't call this one? If you don't call that one,
Object will not be created.
so what happens? Compiler error, crash?
I guess because
What was your name again?
Emirhan.
Emirhan. Emirhan say that object will not be created. Inside me, inside myself, this object will not be created. No, C++ will not let you have an object with an invalid data. If you don't call this one, the default constructor of the base class will be automatically called. So you don't have to call it. It will call exactly the same thing, employee. But in this case, it will not be any different. It will be exactly the same. If you don't call this one will be called. But if you don't call this one here, then what's happened? Then what's going to happen?
Object will not created.
Object will be created with the default constructor. And the default constructor, remember, it set the name to that stupid no name, something like that. So you will get something stupid.
What if I put the default constructor in the private section?
We'll talk about that later.
We said default constructor, but it shouldn't be no parameter.
Exactly, yeah, thank you. Well, what did I say? Everybody is kind of use it default constructor and no parameter constructor. Yeah, no parameter constructor is the much better term. The book doesn't know the distinction between no parameter constructor and a default constructor. They are two different things, yeah. Default constructor is created by the compiler for you if you don't specify it, and default constructor happens to be no parameter constructor. But if you define your no parameter constructor yourself, it becomes your no parameter constructor, but it's not default constructor. Don't ask me to repeat that sentence. I can't. That's too long. Okay, so we talked about this. Yeah. Okay. Yeah, well, it is asking exactly the same thing. Don't do this. Even though writing this code and writing this code turn out to produce the same effect, exactly the same effect. Okay. See, the difference is employees here, no employee there. Don't do this, okay? Write it yourself explicitly. I mean, when I read this code, I don't know if you do this deliberately or if you forget about it, okay? If you are going to do this, put a comment just next to saying that calling the base class no parameter constructor is okay. Okay, good. Your question, Emirhan, right?
Yeah.
What happens if I make my base class constructor private? That's what you asked, okay? Well, the thing is this. Derived class inherits private member variables or member functions. but I cannot directly access them. Surprise, surprise. I inherit everything, but the private data or private functions that I have inherited, since they are private, that's the meaning of private, right? They cannot be accessed directly. They are private. You might say that, well, there is a relationship. I am an employee, right? If I am an employee, where is it? Okay. If I am an employee here, that means that I get to access the employee data member's name, SSN, net pay. Okay. That's the rule, right? No. Well, the object-oriented programming principle says that if something is private, that's private, right? Nobody other than the class can have access to it. Okay? But this is an inheritance. I mean, this is the part of the game, part of the rules. But I am saying that employee doesn't know that somebody is inheriting from it. Okay? I have designed this class in a way that I assume that nobody is going to have access to this private data members. That's it. That's how I designed it, right? Now somebody is driving a new class out of my knowledge, and that class has now access to my private data. That's not acceptable, right? That's why your base classes data members, if they are private or functions, if they are private, is not accessible from the derived classes, even though I have an employee myself. As an H1 hourly employee, I cannot directly access this name, SSN, and net pay directly by name. So I'm going to modify them, use the public interface, set name, set SSN, set pay, and etc. Right? Set pay, etc. Use the public interface. So that's the right decision. You cannot access it. So the public and private works this way. I think somewhere along the line people objected too much. They are saying that we are having lots of trouble. I am using the public interface is too difficult. It is making the things that inefficient and etc. So they gave up and they gave up. They couldn't. They gave up and they couldn't resist people anymore. Okay. Now they have invented this new qualifier, protected. Protected is a C++ keyword. It's public and between public and private. Okay. If you mark a data member or a function member as protected, it behaves like it is private to the outside world, but it's like public for the derived classes. Okay. It's private for the derived classes. So a class can have class A public section, which is available for everybody outside the class, a private section, okay, which is only available for this class A, and a protected section, which is available only for the classes derived from class A. So the designers of this class A know that this protected data may be modified by somebody else if they are derived from this class A. Okay? So that's our third qualifier, member access qualifier, protected. Public, private, and protected. Okay? Many people feel that this violates the information hiding principle. I mean, I am hiding something. If it is hidden, right? I mean, what are you talking about? Somebody from the derived classes can do that and that. Well, if you think that this is violating the information hiding principle, then never use this keyword. Use public and private for your from your derived classes. Use the public interface to set data. Okay, but otherwise it's going to be protected. Well, I am way out of my time. But are there any classes after this?
Yes.
No. There is Erkan Hoca. Okay. Any questions so far?
Protected members are available inside the class, right?
Yeah, protected members are like, of course, for the class A, it is like my privates or my publics, doesn't matter. Good. Okay, I'll see you tomorrow morning. We will finish up this chapter.